So what we looked at yesterday was sine and cosine. Well, the last 2 days we've been looking at sine and cosine. Now, sine of a given angle is equal to opposite over the hypotenuse. Cosine of a given angle is equal to the adjacent side length over the hypotenuse. So we have sine and cosine, and obviously looking at your note sheets or looking at a calculator, you notice that there's 3 of them, because there's sine, cosine, and tangent. Tangent is the other trigonometric function we are going to look at. Now, tangent is a little bit different, because tangent is going to be opposite over adjacent. Tangent is opposite over adjacent. So the opposite side length over the adjacent. Now, the reason tangent is nice is because if I'm solving for a side length, I don't need the hypotenuse. So the last few problems that we did yesterday, where we had to use sine or cosine to find the value of the hypotenuse to find the other side length, well, with tangent, if I just need that other side length, if I'm just finding for that one value, I can use tangent to find it. Because sine and cosine, I have to find the hypotenuse first. So tangent is going to be helpful if we're not given the hypotenuse, but we're solving for a missing side or angle. Now we're going to start off just kind of like what we did with sine and cosine, looking at this here. So what we're going to do is we're going to find 2. We don't have to find all 4. We're finding tangent of S and tangent of R. Now tangent of S. So again, tangent is opposite over adjacent. So what would be the opposite side to angle S? It would be 80, because opposite is farthest away from it. So the opposite side length would be 80. The adjacent would be what? 18. Why wouldn't it be 82? 82 is the hypotenuse. Because the side opposite 90 degrees, the biggest side of the triangle will always be the hypotenuse. Now, they do want us to round it to 4 places, so at this point here, we can plug it into a calculator. We can do 80 divided by 18, which would be 40 over 9. This here? Yep. Right, because we can reduce this down a good bit, and we end up getting, I think it's 4/9 or something like that. Yeah, 4/9 would be 0.4 repeated. But this is the answer. We're rounding it to 4 decimal places, so it's just 0.444. Why is tangent greater than 1 here? Well, right, we're not dealing with the hypotenuse. The hypotenuse is the biggest side. And since we're not dealing with the hypotenuse, where the biggest number has to be on bottom, we can get a number greater than 1 for tangent. Now let's look at R. Tangent of R. To our other side. Yes, it'll be 18 over 80. Because the opposite and adjacent side did what? They switched. Since we switched the angles, the opposite and adjacent side flipped. Now 18 over 80 I'm guessing it stopped at 5. Right. So if they want 4 decimal places, we'll have to add a 0 to it because it wants 4 decimal places. And that's it. Any questions on any of this here so far? All right, right, so this one here, we're finding tangent of A and tangent of B as a fraction, and then rounding our decimal to 4 places. And I think on the homework, it just asks you to find the fraction. Now, tangent of A, it would be, because the opposite side would be 15. The adjacent side would be our 36. And this here would be 0.4. 4168. Okay. Exactly, because the 6 repeating would become a 7. Yes. So 15 over 16 becomes 0.4167. Now B is going to be what? So we're looking at this angle here. The opposite side now is what? And the adjacent side is 15. And we get exactly 2.4. And that's it. Any questions over anything we've done so far? Any questions over this here? Now again, what do we know about these triangles for this to work? It has to be what? All these have to be right triangles. It has to be a right triangle. Now, it's not saying that sine, cosine, and tangent do not work if they're not right triangles, because law of sines, law of cosines works if it is not a right triangle. They work if it is a right triangle. They work in every case. The thing that doesn't work is if our tangent of K, because we're going to find that, and tangent of J, do not equal opposite over adjacent if it is not a right triangle. The sine is opposite over hypotenuse, cosine is opposite or adjacent over hypotenuse, and tangent is opposite over adjacent. Only work if we're talking about right triangles. These setups only work if it is a right triangle. So let's look at this last one here, because I feel pretty confident with these here. So tangent of K, so angle K here, the opposite side length would be what? 32. Now the adjacent side would be 24. And we don't use 40 because it is the hypotenuse. .3333. Now tangent of J. Mm-hmm. 24 over 32. 7 what? 7 5. 0 0. And that's it with these here. Any questions on any of these here? Any questions on anything we've done so far? Okay. Find the value of x and round your answer to the nearest 10. So this is kind of what we did with sine and cosine yesterday, finding missing side lengths. And so we're looking at this here. So we're given the angle of 32 degrees, yes? And we're given 2 side lengths, and neither one of them are the hypotenuse, correct? Well, since we're not dealing with the hypotenuse, because I'm not wanting to solve for it, and I'm not given it, correct? Would I use sine and cosine? Well, no, because sine needs the hypotenuse and cosine needs both of them need the hypotenuse, yes? And I'm not wanting to solve for it, and I'm not given it, is there any reason to use one of those? Well, no. So we're going to focus with tangent. So we're going to take tangent of what angle? 32. Is equal to what over? Opposite side is 11, and the adjacent side is x. So we'll set it up. Tangent of 32 is equal to 11 over x. So at this point here, we would multiply both sides by x because we're trying to solve for x. We want to get x by itself. And the first thing we need to do is we need to get x out of the bottom of that fraction. So we multiply both sides by x because these will cancel out. And that leaves me with x tangent of 32 is equal to 11. Any questions on this here so far? Now is the variable by itself? Oh no, we have what? X tangent of 32. So what do we need to do? All right, we need to divide both sides by tangent of 32. Those will cancel, and we get x equals 17 point what? Let's look at it. I'll close that. Yeah, because we're dividing it. Is going to be the big thing. Now, when we look at this here also, there's another way that we can look at our answer and kind of make sure that we have the right one. And that is, what do we know about sides and angles? The biggest side is opposite the biggest angle, yes? Smallest side is opposite the smallest angle. When I look at this here, we do have an angle of 32 degrees, one of 90, yes? Well, the side opposite 32 degrees is 11, yes? What do I know about the other angle, the one they didn't give me? Will it be less than 32? It'll be bigger. It's actually going to be 58. Yes, 58 degrees. So that side length should be a little bit bigger. And that's just a way to kind of look at it. Are there any questions on this here? Are you good with this here? Yes. It's pretty much exactly what we did yesterday, isn't it? Except now we're using tangent instead of sine or cosine. Okay, we're going to do the same thing here, and we're rounding to the nearest tenth, so 1 decimal place. Okay, so what can we do first? So we're picking tangent because what? We're solving for one of the missing side lengths that's not the hypotenuse. And well, we're not given the hypotenuse. So I'm going to stick with tangent. Our next step would be to multiply both sides by x, because those will cancel. And what that'll leave us with is x tangent of 25 is equal to 12. Now what? Yeah, we would divide both sides by tangent of 25. Because those will cancel, leaving us with what? X is equal to 7 what? 7.3, so we round down to just 0.7. Questions on this here? Questions on any of these here so far? We're good with these here? Yes? Not too bad? It'd be nice if the variable didn't keep ending up in the denominator, right? Because then it'd be a little bit easier to work with, wouldn't it? So let's look at this here. So how do we set this one up? So the tangent of would equal 22 over x, right? Well, now we have the variable in the denominator again, yes? Okay, let's try something a little bit different. It'd be really nice if I knew what this angle was, wouldn't it? Because if I knew the other angle, it's kind of we've seen, it kind of flips, doesn't it?
Yeah.
Which is? Right, because if we add 61 and 90 and subtract it from 180, we would get 29. Or if we subtract 61 from 90, we would get 29, because all three angles in a triangle add up to be 180. Okay, let's see here. What's tangent of 29? Opposite over adjacent. Now the opposite side is x and the adjacent side is 22, yes? Would this make it a little bit easier to solve?
Yep.
A little bit. Because what do I do this time? So I'm going to multiply both sides by 22 because these will. And what that gives me is x is equal to 22 times tangent of 29. So 12.19, which rounds up to 12.2.
So, how do you know when to do all four decimal places and what to just do?
It's going to tell you.
Okay, there it is.
Find the value of x and round your answer to the nearest tenth. Because when we're talking about trigonometric values, so sine, cosine, and tangent, just the values of those angles, it'll probably tell you to go to 4. But here, because we're talking about length, we don't want to go too far past the decimal. And it's all dependent on how accurate you need your information to be. So if we're actually talking, because here, I mean, we're just talking numbers. There's nothing really applied to this here. So it's not that big a deal. If you're talking about actual construction measures, like you're actually building something, you'll want to be more accurate than this here. And this is not from an engineering point of view, but I would almost lean towards the side of bigger or longer is better. Why would that be? Right, if it's too long, I can always take away, yes? Can we add back? Well, no, we can't. If you take a 2x4 piece of wood and you cut it in half and find out it's too short, I can't really add back onto it. It's not going to be as strong. It wouldn't be as strong as if I just left it alone. So you're better off having it be a little too long than it be too short, especially if you're talking about 1/10 of an inch of a gap. It's hard to fix it. So it's all depending on how you round, is depending on what you're trying to do. All right. I think this is pretty much it. There's one other problem, two other problems after this, and we'll look at those. Actually, let's just look at those because they're going to be the same thing. Now, what we have here is a tree. Kind of hard to see it on the projector, but we have a tree. You're measuring the height of a spruce tree. You stand 45 feet from the base of the tree. You measure the angle of elevation from the ground to the top of the tree to be 59 degrees. Find the height h of the tree to the nearest foot. So angle of elevation is just increase. So from a triangle, it's the angle going up. So, do we care anything about the hypotenuse, our length here? Well, no. They didn't give it to us, and we're not trying to find it. So we're going to stick with tangent. So here they gave us the angle of 59 degrees. So tangent of 59 would be what over what? X over 45. That's not bad. The variable is on top, so it's a little bit easier to work with. We don't have to do 2 steps. So our next step would be to do what? Multiply both sides by 45.
I thought we were supposed to put the one number on top.
It's dependent on how it's set up. Because it's always going to be opposite over adjacent. So if we look at the triangle here, so our angle is this one down here, yes?
Yeah.
So the opposite side length would be the height of the tree. So that would go on top. We called it X. You could call it H. Either one works because it's our missing number. And the adjacent side would be? So it's all dependent on how the sides refer to the angle. So it's all about kind of which angle it is and which side's opposite to it and which side is adjacent to it. The hypotenuse is the only one that's really going to stay fixed no matter how we have the triangle set up. Does that make sense? Okay. Right, then we solve for it by multiplying 45 by both sides, and we get 45 tangent of 59 degrees is equal to x. Well, is the variable by itself? Oh yeah, everything else is on the other side. So that means we can plug this into the calculator. We can do 45 tangent of 59 degrees. 8/9, which would be, if we go to the nearest tenth of a foot, would be 74.9 feet. If we don't what? I prefer if you put the units if it gives units. Because as silly as it sounds, putting units is not putting your units or specifying what your units are in the real world can actually be super expensive. It's cost, I think it costs Europe, I believe, somewhere in the billions because of unit measurement issues. It's you can look it up, the International Space Station, because it's pretty much, I think, complete. It should have been completed. Where each of the different countries around the world supply different parts of the overall space station. Yes. The U.S., I think, was one of put theirs up there before the Europe, or kind of Britain's, and we sent them the measurements of what they needed to have so that it would connect to ours properly. They got it up there and realized the units we sent them were not in metric, they were in empirical. 3 feet is not the same as 3 meters, so it didn't fit. So they had to bring it back down, fix it, and then send it back up. So units can be important. So the last one here, we're going to use tangent because, again, we really don't care about the hypotenuse. For this here, we really just want to know the height of the light post. So our angle is what? 70 is going to be what over what? X over 40. Opposite over adjacent, the opposite side length to our angle is x, or kind of the height, our unknown, and the adjacent side is 40. So we're going to multiply both sides by 40 because those will cancel out. It tells us that x is equal to 40 tangent of 70. Inches or inches. Because you can put two little apostrophes up, that is inches. One is, y'all know, feet. One would be feet. And that's it. In the notes. And that would be if you actually had to do it in the book. But